In this fourth section of our 5-part Cloud Journey mini-series, we're going to talk about cloud native development. Cloud native development. Incredibly difficult, even though we've been developing software for a long time. On the one hand, you have this small, discrete service that you can rapidly iterate on at a moment's notice, depending on what the business needs are. And then on the other hand, you have that same service that is inherently secure, ops ready, dynamically scalable, and resilient to any outage. Those two things oftentimes don't go together very easily. So let's start with what this is. Like our heritage with service-oriented architecture, microservices of today are focused on creating a discrete element that is tied to a business service. This discrete element should be boiled down to an individual business service, not a conglomeration of a bunch of services. Things like payments, things like authorization or authentication, things like possibly service record or history lookup, etc. That discrete service talks to all the other services via APIs, and together they form a federation of loosely coupled services that together form an entire business offering. Now, what are some of the key tenets of these cloud native applications? Well, cloud native applications typically are 100% immutable. No human is going around and monkeying with individual code elements. Instead, the code is pushed through a standard code propagation and is delivered every time even a small update is made. This allows you to be certain in the viability of that delivery. Cloud native applications are also dynamically scalable. They have the ability to predict or at least respond to spikes in business load to prevent any kind of business impact. These services also have clear cost metrics by service, allowing you to clearly see how much this individual service is costing. These applications are also natively ops enabled. Now this means that they have the ability to both define when an outage happens, clearly communicate that to the appropriate parties via the appropriate standardized vehicles, and then also recover as much as they can, as much as reasonably to be expected. They also don't have a reliance on any one thing. This often requires cloud native applications to be active-active. This is often very difficult with back-end data systems, but with the technology today, this is actually not a thing that should deter anyone from having a fully active-active system. And finally, from an ops perspective, if the system needs to be updated, if code needs to be rolled, etc., no outage is required to deliver the new service that is being implemented. Additionally, we talked a little bit about security, and while we won't go into a ton of depth, the apps are inherently secure as much as they can be by following best practices and directions from the security team. The apps reduce the amount of exposure of data or services, thereby reducing the attack surface vector. This is just a high-level overview of cloud native development and cloud native applications. But this identifies what is required in the applications of today and tomorrow in order for us to continue to be competitive.